In this video, we will calculate mapping vulnerability of groundwater to contamination by pesticide. Mapping vulnerability of groundwater to contamination by pesticide. So, uh, we'll calculate the vulnerability of groundwater to contamination. What data set we required is this handout, and then we need data sets of aquifer bottom, aquifer porosity, soil type, topography, and elevation of water table. This data set is given us in form of ASCII files. So the ASCII grid files of each parameter is given to us. So contamination to chemicals of the groundwater is a huge problem all over the world. So what happened is the contamination is spilled over the ground, then it passes through the unsaturated zone and reaches the aquifer or the water table. So D is the height of groundwater from surface of the ground surface, and H is the aquifer depth. The first step to calculate is to calculate the mass of pesticide per unit area, which is given by QL. So lambda is degradation rate and T is the travel time. So D is the distance from the groundwater surface to the water table, T is the travel time, V is the velocity through the unsaturated zone, lambda is the pesticide degradation rate, and tau is the pesticide half-life. So what we do is we calculate the concentration of pesticide, which is given by the pesticide per unit area by the pore volume. Pore volume is given by the aquifer thickness multiply the porosity. So in this exercise or in this class, we have the pesticide application rate of 1 kilogram per hectare. There are 3 different soils in the study area. The pesticide half-life in the unsaturated zone is 6 months. The velocity in the unsaturated zone of these 3 soils is given by the following table. Soil number 1 is 1 meter per year, soil number 2 is 0.75 meter per year, and soil 3 is 1.525 meter per year. So what will be the output of this exercise? So we will compute the concentration, pesticide concentration in the aquifer, and we create its map, and then we will also create the map of travel time, and at last we will classify the concentration in 3 zones. What is the procedure to do it? First step is to convert all the ASCII files into the raster format. To do that, there is a tool called ASCII to raster in conversion tools. So what we will do is we will put output data type of all the parameters as float except the soil, which will be an integer value. So let's do it. We have to go to conversion tools, to raster, and then ASCII to raster. Let's go to conversion tools, to raster, then ASCII to raster. Now we will select our first parameter, which is aquifer base. And the data type will be float, and output will be AQ base, the name of the output raster. We will put it into the result folder, AQ base. Click save and then click OK. So first data set is converted to raster. So aquifer base is calculated or converted. Second is our porosity. So it will be also a float data type. Give it a name as porous. Press OK. So we have now our porosity data set. Now we will do for another data set which is our soil. In soil, we will have data type as integer, and output we will put name as soils. Press save. Press OK. Again, now we will convert another parameter, which is our topography or topo. Data type will be float. Output name will be topo. Press OK. Now we'll convert our final data set, which is water table. We'll select float as a output data type and name it as water table WATTABL. Save it. Press OK. So now we have all the parameters converted to raster, which we required for calculating concentration of pesticide in the aquifer. Water table, topography, soil, porosity, and aquifer base. Now our next step is to calculate depth of water from the surface, which is D, and it will be calculated from topography minus the water table raster. So it is calculated from certain reference. So topography and water table is calculated from the same reference, so we can subtract it to get the value of D, which is depth of water table from the groundwater surface. So we'll use a raster calculator, topo minus water table. We will name it as D map, D underscore map. Press OK. So now we have calculated the depth of water table from the groundwater surface. Now our next step is to calculate the velocity. So as according to the table which we saw earlier, each soil has a specific velocity. Soil 1 has 100 cm per year, soil 2 has 75 cm per year, and soil 3 has 125 cm per year. So we will use a reclassify tool. We'll go into reclassify, and corresponding to each soil we will give it velocity value. Select input raster as soils. Now give new value according to these numbers. So soil 1 will be 100, soil 2 will be 75, soil 3 will be 125. For soil 2, 75. And for soil 3, it will be 125. So it's in centimeter per year. So we will give it a name as V map or velocity map, V underscore map. Press save. Press OK. Now you will get velocity for corresponding soil. So we have the depth of water table, we have velocity from the unsaturated zone. So now we can calculate the travel time. So to calculate the travel time, we have to divide the depth of water table to velocity, and we will multiply it by 100 because to synchronize the units. So because our velocity was in centimeter per year and depth is in meters, so we'll convert it. So D map divided by V map into 100. So we'll use raster calculator. So D map multiply by 100 divide by velocity map. We'll calculate travel time for each pixel. So Tmap is created. Press close. So now we have the travel time for each pixel for a specific soil. Now we have to calculate mass of pesticide per unit area in the aquifer. So to do that, we have to calculate QA. QP is given, which is our pesticide application rate. So we are applying pesticides in 1 kilometer per hectare. Our half-life is 6 months. So it will be half a year. So our time unit is year. So it will be 1.3 at our degradation rate. We will put it into the formula of QA. So this formula we will put in our raster calculator to calculate mass of pesticide per unit area in the aquifer. So let's do it, and we will save it as QA map, QA underscore map. Put this formula into raster calculator. One multiplied by exponent of minus degradation rate into the Tmap, which is travel time, minus 1.38 multiply by Tmap. So we will name it as QA underscore map. Press save, press OK. Now our QA is calculated. So to calculate the concentration of pesticide in the aquifer, we need aquifer thickness or saturated thickness. So to calculate the saturated or depth of water in aquifer thickness or saturated thickness, we need to subtract water table from the bottom of the aquifer. So they both are from same reference. So water table minus aquifer base will give us the thickness of saturated zone or the thickness of the water in the aquifer or aquifer depth. Water table minus our aquifer base, we will save it as HMAP. So save it, press OK. So we will calculate the HMAP. So now we have QA, HMAP, and then we can easily calculate concentration. So the formula of concentration of pesticide in aquifer is QA divided by HMAP into the porosity. So let's see it. So we'll use again the raster calculator. QA map divided by HMAP into porosity, or QA divided by the pore volume of the aquifer. And we will save it as concentration temporary map, because we will convert it the units later on. QA divided by HMAP, which is saturated thickness of the aquifer, into the porosity. So we will save it as CA temp map. We press OK. So our concentration of pesticide is now calculated. Now we have achieved this target of calculating the concentration. Now we have the unit which we have is in kilogram hectometer. Now we have to convert it microgram per liter. So this is the conversion formula. So simply what we have to do is we have to multiply C10 map by 100 to convert it to microgram per liter. So we'll save it as CA underscore final map. CA underscore final underscore map. Press save. Press OK. Now we have calculated our concentration in microgram per liter. So just for the safe and side, for creating the zones, we will create a copy of C final map. Simply what you can do is multiply it by 1, so there will be no number changing, and save it as CA reclassify. So that is just a copy, so we can use it later on. We can do this step. Let's do it on raster calculator. CA final map, multiply by 1, and save it as C underscore reclassify. Press save, press OK. Now you have a copy of your concentration, so we can now divide it into 3 zones to create a map. So we have our thresholds, which are 0.1 and 0.5 and greater than 0.5, according to the condition given to us initially into the exercise. So we'll simply reclassify. We will classify it into 3 classes and give it threshold as 0.1, 0.5 and greater than 0.5. So 0.1, 0.5 and greater than 0.5. Press OK. We can give it certain color. So I'm giving green to 0 to 0.1, and then 0.1 to 0.5, light red, and greater than 0.5 for red color. So now you can see that we have 3 zones. Red is high concentration zone and green is low concentration zone. You can create a map, so you can insert the title and the arrow legend into the map layout. So I'm giving it name as zonal pesticide map. We can give it as zonal pesticide concentration contamination map. Press OK. And you can insert the north arrow, and then you can also insert the legend. Place it according to your need to make it a beautiful map. So for legend we only need CA reclassify. So I will omit all and just use CA reclassify. So now you can place it according to your need to make the map beautiful. And once you are done with this, you can export this map to use into any, like, your thesis or paper, or if you want to share with someone, with some organization or authorities, you can use this map. Simply export it and save it as a contamination map or whatever you want.